How do insertion sort works? What is the time complexity of it? Is it good? Let's find it out in today's video. Insertion sort is a sorting algorithm where we insert a key into already sorted subarray by pairwise key swaps down to its right position. So basically we start at index 1 as the zeroth element by definition is already sorted. And then we move towards the end while placing the key at the correct position. Let's visualize it. We want to get the squares in the ascending order. The square highlighted in red will be our key starting from the index 1. We compare it with its previous element. In this case, our key is greater, that means it's already in its correct position. Then we do nothing and move to the next key. Now our key is smaller than the previous element, so we swap it and compare with the other elements to find the correct position for it in the part of array which is already sorted. We repeat these steps until the end of array. We take a key and swap it until it is in the right position. And now we have sorted array. This is how insertion sort works. Let me show you the code for it in Python. Some people use while loops for it too. Anything in a for loop can also be written in a while loop and vice versa. Here for each index I to the end of array, we check if the previous element is greater or not. If it is greater and if we are not going beyond the zeroth element, then we swap it. We do this for all the keys. It is that easy. So why not use it everywhere? Well, even though the code looks short, it is doing a lot of work. If we analyze it, we get the worst case time complexity as big O of n square for the compare and big O of n square for the swaps, which can get pretty bad for larger inputs. Can we improve it? Yes, we can improve the complexity of compares by performing binary search to find the correct position for our key. It is called as binary insertion sort. Then we get complexity of compares as big O of log n, but the swaps are still big O of n square, which isn't good for big arrays. So even though insertion sort is simple algorithm and works for smaller input, it isn't the most efficient algorithm out there for sorting, and we can't rely on it for larger inputs. So this is all about insertion sort. Now go ahead and try implementing it in your language of choice. See you in next video. Till then, keep coding.